Okay, welcome to the motion notes review. This is mostly a vocab kind of review. Um, More of the calculating should be you should definitely reference more of the worksheets I've posted on the website in regards to getting a little bit of practice. But this we're just going to hit on most of the vocab. First thing, you got distance. Basically, how far away 2 points are. Displacement is the next term that is mentioned. Um, Basically, the direction from a starting point and the length of a straight line from the starting point to the ending point. It's the overall direction and total length of how far away you move from where you started. It's a good example here. If you have if you're here, this is your home here, and the school's here. You have the 1, 2, 3, 4, 5, 6, 7 is how far you have to travel. But if you were to go straight as the crow flies, as they say, you could go there in 5. So we call these vector quantities. I'm not really going to get into that too much, but basically, quantity has a magnitude and a direction. This is 1 unit east, 1 unit north, 2 units east. These are what's called vector quantities. So just knowing how far something moves is really not helpful. Displacement really comes in, handy with things like GPS and maps and so forth, because just going one direction 10 miles really doesn't help you. You got to know which way to go, and GPS is useless without displacement knowledge. Motion is simply defined as any change in position. If it's not in motion, it's sitting still. So therefore, it's not changing position. Speed, a little bit different than velocity. We're going to talk about that in a minute. But basically, how the rate of change in position or the rate of motion, what does that really mean? It just means how often are you changing position. So it has to do with if you look at the unit, it's position, right, distance, over time. So the rate means time. So meters are your position. So if you look at it that way. A couple different types of speed. You have instantaneous speed. This is the kind of speed that your speedometer on your automobile will give you. When you look down at your speedometer, it will give you the instantaneous speed that you're moving right there at that section. At that second. If a deer jumps out in front of you, you slam on the brakes, the speedometer will instantly go down. It doesn't have to wait to go down. It instantly goes down. So it gives you your speed at that moment. Constant speed doesn't vary or change. This is your basic cruise control kind of thing. Hard to do without cruise control, which is this little button on a car that makes your speed stay constant or the same. Constant means the same. So, it makes sense if you really know what that word means. You have your average speed. So this is like the third speed definition if you look at the different types. You have instantaneous, constant, average. Average speed is the total distance traveled divided by the total time of travel. That's the real big difference, is the total. You're not looking at any 1 second. You're really looking at the overall distance versus the overall time. For instance, if you travel 60 miles in 1 hour, you are traveling 60 miles per hour. Now, velocity, on the other hand, describes both speed and direction of an object. So it includes that vector quantity that I was talking about a minute ago. It's really what a vector quantity is a velocity. How fast are you going, and what direction? It's not, don't run 10 miles any direction. You need to run 10 miles east or 10 miles west. That's the difference between velocity. Oftentimes interchanged as far as, in your everyday science vocabulary and in your everyday formulas. Acceleration is a little bit different. Let me look over here. Okay. A little bit different. It's how often your velocity changes. Well, velocity is the rate of change of position. So then you have rate and rate, right? And that really means time comes into it twice. So how often does your position change per second or change per unit of time? Tricky thing though about acceleration is it can be described as a change in speed, either an increase or decrease in speed, which is typically the way most people think about it, but it's not just that. But if you change direction, you technically are accelerating too. Why? Because velocity is speed plus direction. Well, if you change your velocity, then you change your acceleration. It's very confusing. You can additionally change both of those. So you can either change your speed or change your direction or change both of them, in which case all three of them are accelerations. So if you slam on your brakes and take a right, you're accelerating, which is hard to understand because you're slowing down. But technically it is a change in speed. Constant acceleration, again, the constant means the same, right? It means the same. So constant acceleration is a steady change at a regular rate. Calculating accelerations really gets a little confusing. This tends to really bog people down. How do you do this? Here are your three formulas if you use your triangle. Delta V over AT. If you remember, delta means change in. This is your more typical formula that you'll use, the A equals delta V over T. It can also be rearranged to find velocity. Delta V is equal to acceleration times time, or time is equal to delta velocity over acceleration. Sounds difficult, but it's, you find if you can remember this triangle or remember the formulas, either way you do it, realize that the triangle is all three of these formulas, right? You cover the A, you have VT, right? That's what A equals. You cover the V, you have A times T. Cover the T, you have delta V over A. Learning the triangle helps you learn all three formulas, and you can use them interchangeably. Depending on the variable you're looking for in the problem. So to calculate acceleration itself, you have to calculate the change in velocity divided by the amount of time. That's where we use the word delta, or the symbol. And what it really means is the change in how fast you were going at the initial, which means the first, to the final, but you subtract the final minus the initial out. So it's oftentimes rewritten as VF minus VI over T, or time. VF is velocity final minus velocity initial over time. Again, like I said, this is basically a review. This video is a review of vocabulary and the formulas themselves and so forth. I suggest that you either pause it here, or you can stop it and go to some of the other worksheets that are accompanying this, the website. I would suggest that you go and practice some of these problems. It'd be a good idea to do that. Reference the video again. Don't close it out. Just kind of minimize it or something, and watch the video again, or watch. Keep an eye on these formulas and so forth. So anyway, I hope it's useful. I hope it's helpful, and I guess I will see you in class.